Did you know that traveling through space isn't like driving a car, but more like sliding on ice? Yes, you heard it right. The vast cosmos is not your typical highway, and the rules of engagement are entirely different. In our daily lives, we're accustomed to the friction between our tires and the road, or our shoes and the ground. This friction stops us when we no longer push or pedal. Now imagine a world without this friction, a world where once you set in motion, you continue moving indefinitely until some other force acts upon you. Welcome to the realm of space travel. In the vacuum of space, there is no air to create friction, and so a spacecraft, once propelled, continues to move. It's Newton's first law of motion at its finest. An object in motion stays in motion, and this, my friends, is the first astonishing reality of space travel. But how do we change direction or speed in this frictionless void? The answer lies in the short, powerful bursts of thrust that spacecraft use. Picture yourself on a frozen lake, standing on a sled. Without friction, you're stuck. But throw a snowball in one direction and the opposite action will push you and your sled in the other direction. That's exactly how a spacecraft maneuvers in space. The engines fire for a short burst, throwing out high-speed gas particles, and the opposite reaction propels the spacecraft in the desired direction. It's a ballet of physics performed in the grandest stage of all, the universe itself. The spacecraft, like a skilled ballerina, pirouettes and leaps across the cosmic stage, propelled by bursts of thrust and guided by the immutable laws of motion. So, space is not like your morning commute, it's an endless ice rink with no brakes. It's a journey that defies our everyday experiences and challenges our understanding of motion. But that's what makes it so fascinating, so mesmerizing, and so utterly astonishing. Have you ever wondered how a spacecraft changes direction in the vast emptiness of space? The answer lies in the principle of action and reaction. Enter the world of thrust, the powerful force that propels and maneuvers a spacecraft through the void. Thrust is a force that directly correlates to the famous Newton's third law of motion. For every action, there's an equal and opposite reaction. Let's break this down. Imagine a spacecraft suspended in space where there's no gravity or air resistance. Now, let's say this spacecraft wants to move forward. How does it do that? The spacecraft uses its engines to expel gases out of its rear at high speed. This action of gases being expelled is the action. The reaction, that would be the spacecraft moving in the opposite direction. Essentially, the spacecraft is propelled forward by the force created by the expulsion of gases. This is what we call thrust. Now you might be thinking, how does a spacecraft steer or change direction with thrust? Well, it's all about the placement and direction of the thrust. By adjusting the angle or the location of the thrust, the spacecraft can change its direction. For instance, if a spacecraft wants to turn right, it will fire engines on the left side, pushing the craft to the right. It's a bit like when you're swimming. If you want to go right, you push water with your left hand, propelling you in the right direction. But there's a twist. In space, there's no air or water to slow down the spacecraft. Once it's propelled in a direction, it will keep moving in that direction until another force acts upon it. This is why precise calculations and timing are crucial in space travel. One wrong move and the spacecraft could end up light years off course. So, when you next watch a spacecraft launch, remember the remarkable physics at play. The engines roar, the gases are expelled, and the spacecraft is propelled into the cosmos, all thanks to the incredible force of thrust. Therefore, steering a spacecraft is like releasing a balloon and watching it zoom around the room. Ever heard of a free ride? In space, we call this a gravity assist. Imagine you're a spacecraft whizzing through the vast expanse of space and you're running a bit low on fuel. What do? Well, you could stop at a space gas station, but there's a slight problem with that. There aren't any. So what's your next best option? You hitch a ride. But how does one hitch a ride in space, you might ask? The answer lies in the powerful force that binds the universe together, gravity. You see, when a spacecraft approaches a planet, it falls into the planet's gravity well, and as it falls, it picks up speed. It's a bit like rolling a ball down a hill. The steeper the hill, the faster the ball goes. In the same way, the stronger the gravity, the more speed our spacecraft gains. But here's the real trick. If the spacecraft approaches the planet at just the right angle and speed, it can whip around the planet and fling itself off into space at an even higher speed. This is what we call a gravity assist or a slingshot maneuver. Space travel isn't all smooth sailing, though. There are some unique challenges to overcome. Imagine this. You're rocketing through the cosmos at thousands of miles per hour. It's a harsh, unforgiving environment out there, and the smallest mistake can spell disaster. One of the most significant challenges of space travel is the exposure to radiation. Unlike on Earth, where our atmosphere shields us from harmful cosmic and solar radiation, in space there's no such protection. This radiation can damage spacecraft electronics and pose serious health risks to astronauts, including an increased risk of cancer. Now, let's talk about space debris. You might be picturing small, harmless specks of dust, but in reality, this debris can range from defunct satellites to tiny fragments of exploded rockets. Traveling at speeds of up to 17,500 miles per hour, even a fleck of paint can cause significant damage. This makes the risk of collision a constant concern for any space mission. The physical effects on astronauts are another hurdle. Long-term exposure to microgravity can lead to muscle atrophy and bone loss. Imagine coming back from a trip only to find that you've lost up to 1% of your bone mass per month. Not exactly the holiday souvenir you were hoping for, is it? And finally, there's the challenge of returning to Earth's atmosphere. The spacecraft has to hit the atmosphere at just the right angle, too steep, and the craft could burn up from the intense heat generated by atmospheric compression. Too shallow, and it could skip off the atmosphere like a stone on water, potentially lost in space forever. So space travel is not for the faint-hearted. It requires courage, precision, and a deep understanding of physics. It's a testament to our innate human curiosity and desire to explore the unknown despite the risks and challenges involved. But remember, every challenge we overcome is a step closer to understanding our place in this vast, incredible universe. Despite these challenges, the future of space travel looks promising. The vast expanse of the cosmos, once thought unreachable, is now within our grasp, thanks to remarkable advancements in technology. We stand on the precipice of a new era, an era where interstellar voyages are not merely the stuff of science fiction, but a tangible reality. Consider the budding industry of space tourism. Companies like Virgin Galactic and SpaceX are developing spacecraft that will allow everyday people to experience the wonder of space. We're not just talking about a select few astronauts anymore. We're talking about you, your neighbor, your school teacher. The dream of floating among the stars, of gazing down at our blue planet from the black void above, is closer than ever before. Now let's turn our attention to reusable rockets. These marvels of engineering represent a significant leap in sustainability and cost-effectiveness. In the past, rockets were single-use, discarded into the ocean after propelling their payload into orbit. But now, companies are developing rockets that can land back on Earth, ready to be refueled and launched again. This is a game changer, reducing the cost of space travel and making it more accessible. And what about Mars? The red planet has long been a target for human exploration and colonization. With advancements in technology and a renewed interest in space exploration, the possibility of manned missions to Mars is becoming more plausible. Scientists and engineers are tirelessly working on solutions to the various challenges such a mission would present. However, it's crucial to remember that these are not just lofty dreams. These are realistic goals that scientists, engineers, and entrepreneurs are actively working towards. The future of space travel is not just about exploration and scientific discovery, but also about the potential for human expansion and survival beyond Earth. So buckle up, the future of space travel is as thrilling as the journey itself.